Assalamu alaikum warahmatullahi wabarakatuh. Welcome to revision for lesson 4 in unit 4. Okay, in geometry, we have follow the lesson, the equality of two or equality of areas of two triangles. Okay, we remember from the previous lesson that if we have two parallel lines and the two triangles have common base like BC common base and the two lines are parallel, the two triangles are between two parallel lines, so the area of the first triangle ABC equals the area of the second triangle BCD. In this lesson we have the converse of this theorem. It means what? It means if we have two triangles already equal in area. So you will see in the given that two triangles are equal in area. When you see two triangles like trousers like this, ABC and the BCD, two triangles are equal in area and they have the same base. BC is a common base between them. Okay. So, and the two triangles are between two lines. So the two lines in this case will be parallel. So we have converse of theorem of the previous lesson in this list. If you see, so since, or if you see, okay, since the area of the triangle ABC, this one, ABC, okay, equals the area of the second triangle, this one, BCD. They are equal in area. If they are equal in area in given, and they have a common base, BC, and the two vertices of the two triangles on a line opposite to this base, so the two lines are parallel. So you can write or you can deduce that the two triangles are, the two lines are parallel. Okay, so let's see the first example. We have here area of triangle ABC equals to area of triangle ABC. So search for the triangle ABC. ABC, all the triangle is equal to the area of the figure DBCE. Look, DBCE. Again, the area of the first triangle ABC, it means this triangle. Okay, ABC like this equals the area of another triangle, or sorry, the area of figure DBCE. Look, DBCE. It means the same part here. Okay, DBCE. It means I will take also this part. It's given that the two areas of the two shapes or the two figures are equal. Okay, so try to search for our theorem that we have two triangles have common base. So I will start solving this question. I want to prove that AE is parallel to CD. So the first part, to subtract the common part between the two shapes. So since I will start, since the given, the area of the triangle ABC equals the area of the figure DBCE, so I will subtract the area of the common part. So search for the common part. The common part here is the area of the triangle DBC. So I will subtract the area of triangle DBC from both sides. If we subtract this part from the triangle ABC, the left will be triangle ADC. So by subtracting, I will see area of triangle ADC equals area of triangle ECD. ED. DC or ACD. Now I have two triangles are equal in area and they have common base. Search for the two repeated letters. You will see DC and DC. So DC here is a common base for the two triangles which are equal in area. So the line which carrying the common base CD is parallel to the line carrying the two vertices. So CD is parallel to AD. And this is the first question. Okay, I wish you understand it. Now another question we have here, ABCD is a quadrilateral, four sides, just shape consists of four sides, ABCD. M is the point of intersection of the two diagonals, AC the first diagonal, DB the second diagonal. They are intersect at the point M. We have given now that MA is equal to MD and also MB is equal to, or the length of MB equals the length of MC. We don't have any area, mister. I want to prove that AD is parallel to BC. Here in this question, to prove that two lines are parallel, I will search for two triangles drawn between the two lines. And the two triangles must be equal in area and also they have common base. So I will try to prove that two triangles drawn between the two lines are equal in area and also they have common base. Okay, if we look at the triangle ABM, this one, and the triangle DCM, number 2. We had studied before in grade 7, first prep, that if the two triangles are congruent, so they have the same area. Okay, so let's see the two triangles are congruent or not. Here we have the side AM is equal to the side DM. They are equal in length or they are congruent. So this is the first element. Now the length of the side MB is equal to the length of the side MC. Also it's a given. They are equal in length. This is second element. And the angle included between the two sides here, AMB, is congruent to the opposite angle DMC. This angle. So I have this case in grade 7, SAS. Two sides and the angle included between. In the first triangle are congruent to their corresponding parts in the second triangle. So I'm sure now that the triangle number 1 is congruent to the triangle number 2. Now the question is, why, mister, you try to prove that the two triangles are congruent? Because the two congruent triangles have the same area. So now I know that the first triangle AMB, the area of it equals to the area of the triangle DMC. They are like the wings of butterfly. So if I add the small triangle up or the big triangle down, any one of them, choose one of them only, okay? If I add it, okay, to each side, I will have the two sides, the two triangles, which are like trousers. So if we add the small triangle here, number 3, if we add the triangle number 3 for the two sides, so triangle number 3, if we put it, or if we add it to triangle number 1, to the area of triangle number 1, so we have a new triangle ADB. And also, if we add the area of triangle number 3 to the area of the triangle number 2, we have the area of triangle DAC. So by adding the area of triangle AMD to both sides, we have now the area of triangle ADB is equal to the area of the triangle ADC. They are equal in area. Now, they are equal in area. They have common base AD, and the two vertices are on a line opposite to this base. Now, I can say that the two lines are parallel. The two lines are parallel. And this is our lesson today. Okay, let's try the third question. I have E is midpoint of CD. E is midpoint of CD. E is midpoint of CD. We had studied before in the last lesson that when I have midpoint, it means EM is median for the triangle DMC. It means area of triangle number 1, which is CME, equals area of triangle number 2, which is EMD, because EM is a median for the triangle DMC. Now, I also have given that area of triangle MAB, where is MAB? This one, I will call it number 3, is equal to the area of triangle MDE. MDE, which is number 2. Okay, so I have now given that area of number 1 is equal to area of number 2 by the median. Area of number 2 is equal to area of number 3, by the given. Oh, 1 is equal to 2, and 2 is equal to 3. So from the two informations, we can now deduce that area of triangle number 1 is equal to area of triangle number 3. They are like the wings of butterfly. So by adding the area of the small triangle AME or the area of the big triangle MBC, if you add any one of them to both, you will get the two triangles which make like trousers. Okay, so they have common base, two triangles equal in area, and they have common base, okay, and between two lines, so the two lines are parallel. So please try to write the proof of this question. Okay, listen to me again, and please try to write the proof of this question. Now, we have also information like this. We know that if two triangles have the same area and they are included between two straight lines like this, and their bases on these two straight lines are equal in length like this, then the two straight lines are parallel. This is also the converse of the information or the corollary we had studied in the previous lesson. In the previous lesson, we said that if I have two parallel lines, so the two triangles which have the same or equal bases are equal in area. Now we have the converse. If I have any two lines, not important to be parallel, any two lines, and I have already two triangles with equal bases are equal in area, so we can conclude that the two lines are parallel. We can conclude that the two lines are parallel. Okay, also even the two bases in this shape. So if you see here, triangle number 1, triangle number 2, they are already equal in area. It's given. And the base of the first, the base of the second are equal in length. So I can conclude that the two lines AF and the second line EB are parallel. Also, if the two bases in this shape, one of them on the first line and the second on the second line, no problem. Okay, now let's see the next question. I have in this question, read it well, please. F is midpoint. Remember, when you see midpoint, it means we have median, and the median divides the triangle into two triangles are equal in area. The median divides the triangle into two triangles are equal in area. Not important to be congruent, but they are equal in area. So if here is midpoint of XY, so triangle number one equal in area to the triangle number two, okay? Because of BF is a median. Now it's given also that the area of the triangle ABF, all this triangle. So if I call this part 3, it means here area of triangle 1 and 3 together, ABF, look, ABF, 1 and 3 together, equal the area of the triangle CFB. CFB, if I call this one 4, it means 2 and 4 together also, okay, is the triangle CFB. So if you read the question well, I want to prove that AC, this line, is parallel to XY. How they will be parallel? If you see two triangles are equal in area, two triangles equal in area, and they have common base or equal bases. Common base or equal bases. Okay, no problem. I will try. Did you know that triangle number 4 and triangle number 3 are equal in area? How, Mr.? Let's see. I will start by the given that the area of the triangle AFB is equal to the area of the triangle CFB. So AFB and CFB are equal in area, like this. It's given. And also from the median in the triangle XBY, I know that F is midpoint, it means FB is median. So area of triangle number 1, XFB, equals area of triangle number 2, FBY. If we subtract this part, number 1, from the big triangle 1 and 3, the left will be 3. And if we subtract number 2 from the big triangle 2 and 4 together, so the left will be 4. Again, so if we subtract the information number 1, that 1 and 2 are equal in area, from information number 2, that 1 and 3 together equals 2 and 4 together. So we take away the same amount from both sides or from each side. It means the left will be that area of triangle CFB, look, CFB minus BFY, or the area of triangle here, this one, this information, the area of triangle AXF, number 3, is equal to the area of triangle CYF. Now I have two triangles equal in area. This is not enough. They have common base or equal bases. In this case, they have equal bases. XF is equal to YF. XF is equal to YF. Okay? So from the two informations now, I have that the line AC is parallel to the line XY. Let's see another question. Read the question well. I have now B belongs to the segment ZY. B is a point on it, such that ZB equals YC. ZB equals YC. I have two triangles that they have equal bases. So what can I conclude now? If they are between two lines, so the two lines are parallel. Also, if they have common vertex, look, they have common vertex now. So area of triangle ABZ, number 1, equals area of triangle ACY. Number 2, this one. Okay, number 2, this one. This one. Okay, so area of triangle ACY equals area of triangle ABZ. They have common bases now. Okay, no problem. Let's complete. Also, we have information that the area of the triangle, AZB, which is number 1, is also equal to the area of the triangle ACX. Look, ACX, this one. Oh, now let's repeat again quickly. We know that area of triangle number 1, or AZB, equals area of triangle ACY. Why, ya mister? Because they have equal bases and common vertex. Okay? So they are equal in area. This is number 1. Number 2, I have given that the same triangle number 1, ABZ, is equal to the area of the triangle AXC. It's a given. So number 1 equals the blue triangle. Number 1 equals the yellow triangle. So the blue triangle equals the yellow triangle, and now they are like the trousers. So they have a common base and between two lines. So the line AC is parallel to the line XY. So please try to write the proof of this question and listen to me to correct your answer. Okay, thank you. Goodbye.